Okay, seemingly all systems are go here, and we can commence with our review for the upcoming exam. This exam coming up Tuesday, right? Next class. So it does say lecture 17 there and 18 here. I guess this is my way of hedging my bets, because if you'll remember, we did fall one slide deck behind when we were talking about strategic interactions. So there it is. Right? As before, we know what the drill is. You just come to class and take the exam, and then I grade it. And I try to get it back to you by the very next class. So that's my plan once again. Just the stuff on the exam, I guess maybe the big takeaway from this slide is that it's not inclusive. It's only the 4 chapters we've talked about since the last exam. There's 6 homeworks, but they're kind of quick, right, and short. And you have 2 extra days to do those, because I believe this upcoming Tuesday is the 28th. So I gave you a couple days there. So if you want to perfect them over, for a day or 2 without the pressure of a looming exam, that's fine too. And then we have 1, 2, 3, 4, I guess 8 slide decks there. Though one is a duplicate, right? For one lecture we use the same deck. And you have a practice exam that I gave you, and I'm going to try to keep to that length. And usually I can't resist just slapping one extra question on, but I'll try to keep it to that length. And so just the material, if you like to organize things this way rather than the previous ways, we talked about perfect competition, right, and freedom of entry and exit, and how you can analyze it in the short and long run. Then we talked about market power. Maybe the big technical development there was this idea of marginal revenue, which was distinct from price. And then we talked about the formal theory of monopoly and how we can compare monopoly and competition. And indeed, that's the very first question of the exam. Game theory and strategic interaction followed that. And the last 2 lectures, we talked about externalities, right, when third parties are impacted by market transactions. And then the surprising Coase theorem, right, which is that, if I had to say it in 10 words or less, problems occur because of imperfect definition of rights, right? The Coase theorem doesn't say that, but it's close, right? So I thought I would just kind of dive right in and look at this practice exam. By the way, I know if you did the exam and graded it, I graded it and got it back to you, but that process was a little bit imperfect because I was doing it under time pressure this morning before the lecture. But at least I got it back. And the online component, it looks like we had pretty good participation this time, so I also was able to get that back to you. More on that. But the grading, there might be mistakes and all of that because it was a quick operation. So this might be the takeaway diagram from that whole monopoly thing. This diagram shows demand and supply with a marginal revenue curve. Now, the thing I didn't do on this diagram, kind of deliberately, is I did not label demand equal marginal benefits, as I've sometimes done. More importantly, I did not call supply the same as marginal costs, right? We've gotten in the habit of writing that S equals MC. The idea was to give you a little something that you had to figure out here, right, from the diagram. So it says, on the graph, mark the competitive equilibrium rent and quantity. Note to self, I don't like the fact that I used rent here and not price, right? Because I had a couple questions about, what do you mean by rent? I was like, well, I meant the price of housing, but it's a little ambiguous there. So anyways, what I had in mind is you would place an X right there where supply and demand cross, right? That's the competitive equilibrium. So I had in mind that you would go put an X right there, draw it right in, and then I had in mind that you would put an O where the monopolistic rent and quantity were, price and quantity were. Now this was a little tricky and it gives me the chance to say this one kind of interesting thing about this monopoly problem, right? The monopolist, right, we saw, thinks of this supply curve as a marginal cost curve, or I shouldn't say thinks of it that way. The supply curve is the monopolist's marginal cost curve. The monopolist maximizes its profits where marginal cost and marginal revenue are equal, right? But to find out what the price is, you have to go up to the demand curve and get it, right? So what I had in mind is you'd put an O right here, or a circle right there at this point, and the most common mistake people make is putting the circling this point. That would get the quantity right, I guess, but not the price, right? So that was the big innovation, or the big potential stumbling block there. Now the rest of this is just kind of reading carefully and reading off the diagram here. So rent in the competitive market, that's just where demand and supply intersect. You can see quantity is 600, and therefore rent is 150, right? Consumer surplus in the monopolistic market. Ooh, okay, so this was, by the way, another little stumbling block for folks taking the exam, was reading this term, the first term in the question, and then the second one. So people sometimes just consumer surplus, and then they just did the competitive market, not the monopolistic one. So I guess it's like the classic thing, read carefully, like my son when he takes his practice SAT exams, he'll grade, oh, I got 5 wrong. I just made dumb mistakes. It's like, don't, come on, man. Pay a little attention. But anyways, what would this consumer surplus be? Well, you have to have found the price correctly, and we found that the price was at 200 in the monopolistic market, right? That was from where these two cross, you go up there, and that's 200. So what we want is the area, we want consumer surplus, the rule is always the same, the area below demand but above the market price. So that would be, the distance would be 200 to 300, that's 100. This distance here, I believe, is 400. So 100, let me just make sure I got all these numbers right. Yep, 400 is the quantity, 100 is the distance. 100 times 400 is 400, or 40,000, right? Divided by 2 is 20,000. I think I did that in my head. So that would be the correct answer there for consumer surplus in the monopolistic market. 20,000, right? Producer surplus in the competitive market. Okay. So once again, we want to stick to our guns and just apply the regular rule, which is if you want to think about producer surplus as everything below the going price but above the supply curve, right? Or the marginal cost curve, as you kind of have to picture it as. So in the competitive market, well, let's see, here it's lower on the picture, so I can tell you it's this triangle like this, right? So that's going to be 0 to 150 is kind of the base if we look at it this way. And this distance is 600. So we go 600 times 150. I'm going to have to do this out here. 600 times 150. And then we divide that by 2. I think that's 90,000. 45,000, right? I think I got for once I got the zeros right. I messed those up a lot. But I think that's the 45,000 is the answer there. Rent in the monopolistic market, well, we've already kind of worked with that. It's where it's the price that corresponds with marginal revenue and supply equals marginal cost. It's where they correspond. You go up and get the price, it's 200. So there we go with those first 1, 2, 3, 4, 5. Ooh, this is exciting. We have a little bit of a game theory problem here, right, where we're trying to do strategic interaction. Hopefully you got my email where I sent along a little video where it's a pretty low, it's not a well-crafted, production like my videos from class are. It was a joke. But anyways, it did kind of attack the problem in the same way that I described it, which is one reason why I picked that video. By the way, there's a lot of great videos out there, and if you happen to find one, I have copies here of the practice exam if you want to take one now or later. You can do that. Anyways, so we have this little matrix here which describes payoffs, and I'll remind you, Coke and Pepsi here are the two competitors. Coke chooses the row strategy. Pepsi chooses the column strategy. Coke's payoffs are listed first, right? That's the convention. Pepsi's payoffs are listed second, right? So, let's see what the question is here. What is Coke's best response if Pepsi decides to spend a little on R&D? So what I was thinking you would do is you would say, okay, well, if Pepsi has already decided to spend a little, that puts us in this column, right? Now what Coke does is looks at these first two numbers, right, and decides which one is better. And so spending a lot gives Coke 400. Spending a little gives Coke 300 when Pepsi spends a little. So Coke's best response would be to spend a lot, right? Now, even with my practice exam, I was kind of experimenting with the best way to ask questions like this. Really what I had to, I don't know if this is the best way to do it, if I should have circles or if I should have multiple choice answers, things to circle. Because even then I get, even on there's like 5 people who did who submitted the exam for grading, so it wasn't a lot of people, but even then, some people wrote spend a lot, right? And some people wrote 400. And so I guess I could technically grade both of those as correct. But really when I'm asking about a best response, I'm asking not about a payoff. I'm asking about what the action is, right? So I would want you to write spend a lot or something like that. But I'm still trying to think of a better way to ask these questions. Okay, what is the Nash equilibrium? So you can see here my question 7 is another experiment in the way to ask a question like this. So Nash equilibrium, right? Remember, the key thing that you should keep in your mind is always this idea that a Nash equilibrium is when best responses are responding to best responses, right? Best responses to best responses. So one thing we can start off with, we have already done a little bit of this analysis. If Pepsi, and this is one way to do it, is to there's 2 ways to do it here. I'm going to get to both of them. If Pepsi has spent a little, Coke's best response is to spend a lot, we just saw, right? So we know right off the bat that this is not a Nash equilibrium, where both firms spend a little. More on that in a second. So Coke's best response to spending a little, Pepsi spending a little, is to spend a lot. So if we take this row, what is now Pepsi's best response? Well, spend a little, Pepsi gets 100, spend a lot, Pepsi gets 200. Pepsi's best response is to also spend a lot. So we say, okay, Coke spends a lot, Pepsi responds by spending a lot. Now we can say, what is Coke's best response to Pepsi spending a lot? Well, let's see here. If Pepsi spends a lot, Coke could spend a little, or spend a lot. 200 is better than 100. Coke should spend a lot as well, right? So now we have a Nash equilibrium. When Coke spends a lot, Pepsi spends a lot. When Pepsi spends a lot, Coke spends a lot. When Coke spends a lot, Pepsi spends, right? So you can kind of say that nobody wants to change what they're doing. Everybody is best responding to everybody else. In that sense, it's a Nash equilibrium, right? The game should settle at this point. Okay, so there's another way to solve this. And then there's an interesting question that students always ask. So I'm going to get to that in a second. One thing you can do is also look and see if any firms have dominant strategies, or if any of the players have dominant strategies. What is a dominant strategy? It's one that always gives a higher payoff. There's no reason to ever do the other strategy if there is a dominant strategy. So, for example, if we look at Coke, when Coke spends a lot, the possible outcomes are 200 and 400. Yes? When Coke spends a little, the possible outcomes are spend a lot and spend a little. Are 100 and 300, right? 200 is always greater than 100, 400 is always greater than 300. So Coke should never spend a little. Put another way, spend a lot dominates spend a little. Put another way, spend a little is a dominated strategy. The final way I'll put this is spend a lot is a dominant strategy for Coke. Right? Same is true for Pepsi, right? 200 is greater than 100, 400 is greater than 300. So both firms have a dominant strategy here. And that's another way to find this Nash equilibrium. Final thing I'd like to say about this little payoff matrix is that students invariably, and it happens, it's a hard idea to get used to, so this is why I'm going to say it again. They say, well, why isn't this the equilibrium, right? Everybody's better off here at 300, 300 than they are here at 200, 200. Yes, right? That's kind of the point, is that the equilibrium occurs away from the place where the firms maximize their joint profits, right? Firms are competing away their profits. That's one of the surprising or interesting things about this prisoner's dilemma game, right? Which is exactly what this is that firms wind up doing what is not in their collective best interest, right? So in this case, we like that. As consumers, that's good. They can't collude, right? They can't kind of do what's best for the industry. They wind up doing what's best for the consumer, put another way. Of course, if we think about other interpretations, remember my fishing interpretation, or if you remember my cleaning up, my environmental damages interpretation, or my arms race interpretation, it's not always a good thing that individual actors trying to do the best for themselves wind up doing something that's jointly not the best for everyone. So that's I've snuck in a lot of review there by way of answering number 7. Okay, so this exam, on the practice exam, this way I put the question together. I was pretty happy with how people were able to interpret this particular diagram. And I think it was because I put this dashed line in here, which is redundant. I will talk about that in a second. This is an externality problem where you can see here that D is the demand curve for the product. I've written supply equal PMC. Does anybody want to guess what PMC stands for here? Private marginal cost, right? By private marginal cost, what I mean is that these are the costs that the firm pays when they produce the product, right? So, for example, if we're talking about aluminum smelting, this is what you pay for the raw aluminum. I don't know what it is. Raw aluminum, I guess. This is what you pay for the power and the building that you use, your employees, all of that stuff. It comes right out of your pocket if you're the firm smelting aluminum. That is, however, different from the total costs of producing aluminum, which should include what I have up there is MSC, marginal social cost, right? It should include things like using up clean air. That's a resource that's being used. And so one way of thinking about what I've put down here, damages, is these resources used by the firm that are, effectively damages to a third party. Now, why did I say this was redundant? Well, if you take this curve, right, this flat line, which suggests that each unit produced does $2 of damage to the environment, right? If you take that and you add it to this curve, you get this curve, right? That is to say, these two curves are exactly 2 apart along the whole way. So it's kind of the vertical sum of 2 curves. So it is redundant to also have to include that on the diagram, but I think it's helpful for calculations and all. When I teach law and economics, that's like my bread and butter is vertically summing curves like this. So it's kind of a fun thing to know how to do. Yes?
So let's say in the future, when we're not line isn't included, we can always assume that it's going to be the sum of 2 curves, however many points they're apart.
Yeah, that's in this sort of problem, yes, right? The question was you sort of think about adding up different sorts of costs, it should be a vertical sum. Yeah. It's a neat little thing that's maybe not an obvious. One thing back in the old days, I'll talk, if you hear I'm shamelessly plugging my own classes as we get close to the end of the semester. If you ever take my history of thought class, doing everything just in terms of graphs with no math was a really big deal in economics in the 30s, 40s, 50s, and economists are quite good at it to this day. Just doing graphical math, adding graphs, subtracting them, horizontal sums, vertical sums, all that. Anyways, what are the questions? The competitive equilibrium quantity, first question, well, that's just where private marginal costs equal supply and demand costs, so that occurs here at 4. Right? So that would be the answer there, 4. The total external damages in a competitive equilibrium are what? Okay, so we figured out the quantity is 4. This curve suggests that the per unit damages are 2. So if we multiply 4 times 2, we get 8, which is the total damages, right? It's just this rectangle here. If you prefer, it's the trapezoid going from 2, 4 all the way up to the quantity 4 there. Same exact area. In fact, if you're looking for something to do this Friday night, you can have some fun by just showing that trapezoid and that rectangle have the same area. That was another joke. Too early for that. Wrong crowd for these jokes. Anyways, the socially optimal quantity, well, we would like it if producers also thought about their damages that they were inflicting on the environment, right? That is to say, we'd like it if producers took into account all costs, which would be reflected in the marginal social costs. So you might even think about that as the ideal supply curve, right? The socially ideal supply curve. That would be here at 3, right? 3, and so you can think about this a bunch of ways. The actual or the ideal price of this product would be 7, and the ideal cost would be MSC, which with the production of 3. And then we have the total external damages, same exact thing. It's just if we could somehow produce 3, right? The damages would just be this rectangle here, right? 6 would be the answer. So one thing I didn't throw into this question, hint, hint, is I didn't say what the corrective tax would be that would cause this industry to work to function in a socially optimal way. That's $2 per unit produced, right? Why is that the case? Well, if you put a $2 tax on producers, it's like making them pay for each unit of damages they cause, right? Put another way, it's like making them pay for using the free resource. I said tax on producers, but going back into class maybe a month and a half or so, you know that it's irrelevant whether we place the tax on producers or consumers. The same result will happen, right? That was part of our tax incidence analysis. But a $2 corrective tax would be the answer to that question that I did not ask. Here we go, another game. I have each of 2 players have 2 actions, and I give you a little bit more detail about the game. Once again, I was experimenting a bit about how to ask questions like this. So I say circle the Nash equilibrium payoffs of the game, and so in this way you kind of have to solve the game. You can use your usual bag of tricks here. You can guess a strategy. For example, what if row player picked B? What is the best response of column player? Well, if we're focused in this row, column player is choosing between 3,000 and 1,000. 3,000 is better, so column player's best response is to choose little a. So when B is chosen, A is the best response. Well, now we can flip it around and we can say, well, what happens when A is chosen? Well, now row player is thinking about choosing between B, which gives 1,000, and A, which gives 4,000. Clearly this is better, right? So little a, the best response is big A. So that seemingly puts us here. Let's check. When row player chooses A, well, let's see, column player is choosing between 2,000 and 500. Little a is the best response, yes? So now we have, okay, little a, best response is big A, best response is little a. What I would have in mind is that you would circle this, right? That would be the best, that would be how you could do this. Of course, you could also use the dominant strategy trick, and you could say, Baker, you just wasted our time because 4,000 is greater than 1,000, 5,000 is greater than 15,000. Capital A here is always the best strategy for a row player regardless. So this is a dominant strategy. Oh yeah, and it looks like 2,000, 5,000, 3,000, 1,000. Little a is also a dominant strategy. So that the game was, you might say in the professional lingo that the game is dominant solvable. Okay, so a couple of multiple choice questions coming in here. You'll remember how we talked about the hoteling model. I think my example was from Orchard Beach. So it was a model of spatial competition where the firms wound up in the middle, right? So to speak. So it was an idealized situation where firms were situated along a line segment, right? Customers were evenly distributed along this line segment. The producers produced exactly the same thing at the same price, so the only problem was where to locate. And we saw that Nash equilibrium logic led both firms to land right in the middle, right? And so C is the right answer. Both locate at the center of the segment. And so once again, this is a great model for showing, for explaining why those gas stations cluster up at the same exit along the highways. But it's also a general result in economics we point out, saying that, location is one way products differentiate, and this suggests that firms don't always differentiate in a way that we would like. Which of the following best describes the Coase theorem? A, government intervention is always necessary. That wasn't really the spirit. B, if property rights are well defined and transactions costs are zero, efficient outcomes occur regardless of how we allocate rights. Right? That seems to be exactly the way we said it. Right? Whether or not in our examples we gave the rancher the right to let his cattle run free, or we gave the farmer the right to be free, right, from trampling. If bargaining was allowed, we saw that the problem of trampling would be stopped, if it should be, in the most efficient way possible. Is kind of how we put it there. So that was kind of the idea there behind the Coase theorem, and the video is still there, and it passed all the copyright checks when I posted it. All the My Little Pony stuff is still there as well. Okay, so this is kind of the, if you want to think about first thing coming last, this was the big picture of a competitive firm that we settled on, which we derived from first principles. Derived from first principles. And really it says about everything we need to say about a competitive firm here. So in a competitive industry, firms just take the price as given. And so what I'm kind of testing here is your ability to find the point where price is equal to marginal cost. So I say that's where firms maximize profits. When the price is 14, quantity produced would be, well, let's see here. Right here, yes? Because that's where price and marginal cost are equal. So intuitively, someone asked about this, and I haven't yet. I've had a bunch of emails because it's also registration. But you can also see what the firm gets out of this decision by looking at this, which is the difference from price and average cost when the firm is maximizing profits, right? This is the profit margin. How much you're making per unit. Here's price, here's average cost. So this rectangle here, all the way across like that, if you can kind of see what I'm trying to do, would be the firm's profits, right? The number of units produced times the profits per unit. Oh, this is an interesting question here. If there's freedom of entry and exit into the industry in which this firm produces, in the long run, the firm will produce what, and the product will sell at a price of what? Well, we saw that what happens in the long run with firms is that an entry and exit is that profits, right, suck firms into the industry, and losses cause firms to exit the industry. So in the end, what happens is firms make zero profits while they're maximizing profits. It turns out, because of geometry, which we discussed, this is possible here, for firms to be maximizing profits and yet not have any profits, right, any economic profits. Remember, that's a distinction we make. Well, that occurs at this point here, right? If we put a price at 8, firms maximize profits where marginal cost and price are equal, and price is equal to average cost. That's the zero profit point in the long run equilibrium here, where firms produce 8 units at a price of 8. I'll just, once again, I'll take a second to just throw in a little bit of extra information about this. As economists, we love this because it suggests that competition in this industry makes our firms produce as efficiently as they possibly can, right? Minimal average cost. You might think about that as using as few resources to produce a unit of output as possible, right? And so that's kind of the long run situation. And that's kind of the end of that. 8 and 8, yes. I kind of don't like that, so I might try to, if I do this on the exam, I might make it so that the numbers aren't exactly the same. But the practice exam, I'm operating under pressure. I have to get everything out here for you to use. So what I'll do is I'll fire up this attendance here for a moment. We'll do a little attendance. I remembered. And I'm going to try to minimize this as we switch over to the online questions. Let me see if I can do this. Oh, that's a little small. Maybe I should write it over there on the board. Let me just try to kind of see what happens here. If I... Come on, man. Okay. So I think this will work out okay here, and I can kind of go through these questions as well. These were the online. It's a little small. Let me see if I can do a little bit better here. Oh, I made everything bigger. That's okay. All right. This will work, I think. So the following question is about this diagram here, and this is, I think it'd be tough to throw this on an exam, but it nonetheless gives you a little practice with how to do this. I say here's a good where there's a marginal, where there's an externality, and I say, what is consumer plus producer surplus if you're forgetting about the externality here in a competitive outcome? So really all you're doing is saying, all right, well, I know that this is the competitive market outcome, and now the surpluses are as usual. Usually you have a line going across and it's consumer and producer surplus. Here I'm just asking you about the sum of the two, so it's just A plus B plus E. So I don't know. I mean, I don't think I would ask a question like this on the exam, but there are the answers. Let's see how people did. Huh? A plus B plus E. Yeah. That. So it looks like most people got that right. It's interesting that participation is much higher on the this online practice than on the actual upload to Gradescope. So, yeah.
Can I ask if you, even though you're going to be showing the answers, would it be possible for you to make this available?
Yeah. If you want to do this after, yeah. So you can send me an email. I usually make the actual exam and then I make a copy of it so I can open it up again. I guess that would be fine, and I could cut it off sometime Monday, so you get the answers and all that. But you could, of course, just look at this to get the answers too. Yeah, if you want to do that, that's fine. Just fire me an email, and I'll take care of it.
I assume it was going to be open until like Monday.
Yeah, that's a good assumption. But I wanted to close it down so I could do this, what is it, the $64,000 question or whatever it is? Who wants to be a millionaire, where they have all the bars blinking on the, anyway, whatever. Okay, so same diagram here. The market for a good, right? But now I'm asking about social surplus. So this is a little trickier. Because now what you want to do is think about consumer plus producer surplus, yes, minus damages. And here, notice I haven't given you the handy dandy, well, the per unit damages should go like this, right? I know this because these two curves, I'm kind of working backwards from everything I told you before. But you can still figure it out here. You can say, all right, well, let's see, total damages are going to be B plus E plus D. That's this. Now we have the trapezoid, right? So what we want to do is say surplus, consumer surplus here. This is a really hard question, by the way, so if you get this, that's good here. I'll draw out some stuff here. Maybe I'll try to do it with a little bit more detail. So here's the diagram that we have there. MPC, not to be confused with NPC, which apparently is an insult. Here's MSC. The jokes are just going over terribly today, right? Well, I actually had a joke, and I was thinking it's kind of a joke about the Old Testament and that stuff, but maybe one day I'll tell it. So anyways, let's just kind of reproduce this. This is A, B, E, and D, right? Like that. And usually what you would do, this is demand, quantity, and I guess price in dollars, or dollars is probably better. Usually what you would do is you would say, okay, well, whenever we're doing any sort of market analysis, what we want to do is just kind of think about the price. This area up here is consumer surplus, right? And then this area down here is producer surplus. In our standalone market, that we would be done, right? Consumer plus producer surplus is welfare. But what we have to do is we have to now subtract out damages. So what are damages in this case? Well, I said in my picture on the practice exam, I gave you kind of a horizontal line like that showed you per unit damages this way. They're not on this diagram. But I also mentioned that we have this vertical sum here of these two curves. So you could just as easily look at the area of this trapezoid as you could of this rectangle. So maybe we'll do that here. And we'll see here that damages then are this area here, right? So now to take stock of all this, we would say welfare, I'll call it societal welfare, is A plus B plus E, right? That's consumer plus producer surplus. But we have to subtract out damages, which are minus B minus E minus D, right? So, call it damages. I know hopefully you can see all that. So in the end, we wind up with B and E cancel out. We have A minus D as the final answer there. So let's see if we got that right. This is a really tough question, and I'll be interested to see how people did on this. So let's see. Show the correct answer. Show responses. Not bad. That's well done. That's for those of you who did this, it's not an easy question to answer here. Oh boy. I know you're getting tired of these, but we'll tackle one more. Marginal private costs, marginal social costs, and marginal benefits. Okay, so they've now changed the demand labeling. What are total damages done? Well, we kind of worked it all out over there. You can see that they are at the market equilibrium, G plus H plus J, right? that trapezoid, which is the same as the rectangle that I gave you on that. So it should be B. And you guys did pretty well with this. I don't know if what else to say about that. That's pretty impressive. That's not easy stuff here. Question? Let me just put this like this. I'm just kind of... Okay. Question 4. We have this diagram here. Assume that each unit of output results in a marginal external cost of $5. Which combination below represents the socially optimal level of output? Okay, so this is a little tricky. What you want to do is you want to sort of say, all right, well, let's see, we should add to this supply curve 5 units at all positions, right? So instead of 0, this will be 5. Instead of 1 here, this should be 6. Ooh, and I guess I've done it, right? So if you were to draw this curve and shift it up 5 units, you can see that it would go from 5 and hit 6 there. So the socially optimal level of output should be 12, right? I know it's hard. I kind of did that quickly on this diagram, but we'll see what happens here. People are doing well in this practice exam. Suppose that at a monopolist's current output, marginal cost equals price. Which of the following statements is true? Well, first of all, we know that competitive firms want to get marginal cost equal to price, but that's not typically what a monopolist wants to do, right? Maybe I'll draw a little diagram here. And we'll just think it through here. This is a worthy question. So, if we draw out the classic monopoly diagram, it kind of looks like this. Here's demand, quantity, price, demand, supply, and marginal revenue like that. The monopolist typically wants to find this point, right? That's its optimal amount, and then you go up here and you find the price. So you can see the monopolist typically produces at a point where price is a lot greater than marginal cost, right? So if this firm is producing where price equals marginal cost, well, the monopolist can't be doing A. It's not maximizing its profits. This here maximizes profits. The monopolist should produce more. Well, if marginal cost and price are equal, that suggests that you're at the competitive point here, right? So the monopolist is kind of producing too much if it's trying to maximize its profits. So it looks like C should be the right answer. It should reduce its production. By the way, this is often, these are tough. You guys are, whoever did the practice exam, good job. By the way, this is often the sort of question that you might use your knowledge of economics to answer practically if you were doing prices, right? So it's a frequent question in actual business, is our price too high or too low, right? And the thing to do is to calculate out, think about what marginal revenue is at that current price and think about what marginal cost is, and then you can advise, right? Clearly, you would tell this monopolist you should raise the price and lower the quantity. So this is a related question. If a firm holds a pure monopoly in the market and is able to sell 5 units at $4 and 6 units at $3.90, it will produce and sell the 6th unit if its marginal cost is. These are hard. I like this. These are probably harder than I would ask. But the first thing you want to know here is, what does this suggest marginal revenue is from unit 5 to unit 6? Well, let's see here. We have 5 times 4 is 20. Well, that gives us 20 of revenue. What is 6 times 3.9? Well, I'll do it out on my trusty phone here in a second.
23.4.
23.4. I'm going to see if I have an idea here. I just want to check. It's not that I don't believe you. What is 6 times 3.9? 23.4. Well done. Okay. So we do increase revenue here, but you can see here marginal revenue is then 3.4, right? Once again, notice that it's different than the price, which is 4. It's less than 3.9. But we would then say, well, when should the monopolist produce this unit? It should, so long as marginal revenue is greater than marginal cost, right? That would be like we're on this side of the diagram here. So the monopolist should produce more so long as marginal cost is less than this 3.4, this marginal revenue. Man, is that a hard question too. So B is the best answer, and wow, good work. I mean, I guess people could be plopping things into AI, but why would you do that on a practice exam? I guess that would even be useful, right? You get an explanation as to what's going on. So I shouldn't be. I mean, that's kind of what I do a lot. When a monopolist increases sales by 1 unit, it gains some marginal revenue from selling that extra unit. True. B, more low-priced sales cause negative marginal revenues. That's true. It has to lower the price of all the other units that it was selling before. Remember my haircuts from slide deck 12, I think, right? C, every other unit must now be sold at a lower price. That's also true. So it looks like all of the above is true. And that's what we get here. How am I doing on time here? We're doing good. A monopolist is able to maximize its profits by, I'm just going to see here. B looks good. I see MR equal MC, right? That's kind of what I described there on the diagram. And charging a price along the demand curve. That's a nice compact way of saying what the monopolist does here. Setting output at MR equal MC and setting price at the demand curve's highest point. It would be great if you could do that, but you can't, right? So B looks like the best answer, and we just kind of showed why D is not the best answer when we drew up that graph. The slope of the demand curve for a monopoly firm is what? Well, I don't know if we use this exact terminology, but we saw that for a monopoly firm, is D, just downward sloping, right? The monopolist faces a downward sloping demand curve. The rest is just misdirection here, and almost no one was fooled. Question 10 here. If monopolists are able to produce fewer goods and sell them at a higher price than they could under perfect competition, the result will be, elimination of barriers to entry? Not really. Irregularly high, unsustainable profits. Well, I would say high profits, but they should be sustainable too, right? If the monopoly is a monopoly, it means no one can enter. C, government deregulation. That seems kind of like a nonsensical here. D, now that one's speaking to me. Abnormally high sustained profits. And the majority of people got that one right too. If large numbers of individuals choose to behave as free riders, question 11 asks. So we didn't really talk about this at all. So I didn't have time to sneak in any talk about public goods. But suffice it to say, a public good is something that is free for everyone to use. Theory suggests that people will use the good without paying as much as they should for it anyways. So the correct answer, I should have taken this off, by the way, because we didn't really have time. If large numbers of people free ride, B is something that could happen in an extreme case. Public good may never be provided. So, yeah, that one I'm not surprised people got wrong at a higher frequency. By the way, if you're interested in these sorts of things, public goods, environmental economics is a great place to study it. Public finance is another class we offer where you think a lot about how do you pay for things that everybody can use. Just 2 examples there. Raven Farms raises a lot of bees and uses the honey to produce a skin healing cream. It's next to Oak Creek Apple Orchard. The bees pollinate oak trees. Raven Farms. Okay, so Raven Farms, what they're doing is providing a positive externality. We've always had, all of ours are negative. One way of saying this is you might say it provides social benefits that it gets in private benefits, right? So for example, Oak Creek sells all of its apples and enjoys the profits from so doing. All that, and this of course has something to do with what Raven Farms does, but Raven Farms of course is just worried about selling honey, so external benefits are accruing there, and it looks like people did their best. We didn't talk a lot about that either. Once again, that's a great subject for an environmental economics class that we didn't have time for. For a positive, all these positive externality problems. This is like the last one. Private benefits are less than social benefits, right? So people soldiered through these questions in pretty good fashion. I appreciate that. So why so many about a positive externality? I apologize for putting all of these here, but there they are. So the appropriate public policy response would be to you might say develop ways to provide a greater share of the societal or social benefits to the innovator. We're actually going to talk about that when we talk about economic growth and innovation and all of that. Okay, so that was a quick blow through of a block of questions that I'm not going to ask you about. But, it's not bad to touch on things of that nature here. So here we have a monopolist facing a demand curve, right? We have quantity and price. And I ask, what is the marginal revenue from the fourth unit produced? So 0, 1, 2, 3, 4. This would be when we go from 3 to 4. What is marginal revenue here? So this is not, I'm looking at this is not the best way to ask a question like this. So I would probably want to clean up my quantity price table. But let's see, when the monopolist is producing 3 units, the price is 3. So that gives us revenue of 9, right? When the monopolist produces the fourth unit, the price is 2. 4 times 2 is 8. So that gives us revenue of 8. So the marginal revenue here is actually negative, right? By producing that extra unit and lowering the price, you actually lose money. So it would be -1. Crazy. That can happen though, right? The correct answer is -1. And okay, almost everybody got that. Good. I thought someone would put 1. So you can see here the 8 is the revenue, so that was another popular misstep here. Same question. If the marginal cost of producing the good is constant at $2.90, what quantity would the monopolist produce and sell to maximize profit? So you want to keep calculating marginal revenue until you get a quantity that's less than $2.90, right? So the first unit is 5, right? 1 times 5 is 5. The second unit gives us 8. So the marginal revenue is 3, right? From going from second unit. The third unit, well, we go 3 times 3 is 9. So that marginal revenue is 1. So we're kind of done after 2 units. We would say that this monopolist will produce 2 units because that's as close as you can get the marginal revenue to the marginal cost without going over. Again, that's a tough question. But I kind of like the fact that these practice questions have been a little challenging and people have been able to kind of do that. So 2 units was the right answer. Okay, so we know what this diagram looks like. This is back in the when I used to have to draw these diagrams by hand. You could see how I went about doing it and putting numbers in and all that. What does the figure suggest the amount of the externality per unit good produced is? So I'm kind of asking you, what are the damages? So once again, I'm hopefully getting used to the idea of saying, okay, well, this this vertical difference kind of measures damages between MSC and MPC. If you can picture the rectangle kind of going across this way, it suggests that the damages per unit are 12, right? Because that's what we're shifting the curve up by to get the marginal social costs. So, why do I keep getting that? All right, good. Wow, impressive. In a competitive market, the next question is, well, we can say that the competitive market just worries about marginal private costs. And so in the competitive market, that should be 24, right? So that was the right answer, and most people got it right. Another question, so you know my rule is that if I'm going to draw a diagram, I should use it for multiple questions. The total cost of the externality on society at the market equilibrium. Okay, so here, well, let's see here. We figured out that the per unit cost is 12, right? The competitive quantity is 24. So we'd want to go 24 times 12, right? That is to say, if you can picture the rectangle going like this up to this competitive market quantity, 24 times 12 is 280? 288. So let's see. Whoops. It looks like my answer key is wrong here. And the masses, of course, the wisdom of crowds, right, was more correct than my answer key. So I had that one wrong. I'll have to fix that. I bet what happened is I changed the numbers around a little bit and forgot to change the answer key. So 288, correct answer. Yeah.
I don't know if I'm on that topic. I think for homework chapter 10, I think it was question 3. Like, no matter what answer we put, it came out wrong. I even did like the true response.
No matter what you do. No matter what you do, it's just wrong. If you can send me an email, I can fix it. Yeah, I appreciate it. If you spot stuff like that, please let me know. It helps everybody. It's a public good, correcting the test. So we know it will be underprovided, but maybe I can give you accolades, and that will give you an incentive to help here. Anyways, consider this diagram here. Cost and demand in a market. If a monopolist was operating in this market, how much would the monopolist choose to produce? Now this question, I've kind of gotten away from showing the AC and MC and all that stuff in the monopoly. So this is kind of an artifact from those days, but you wouldn't really change how you would do this to figure out production. You'd sort of say, well, where is marginal revenue and marginal cost equal? Well, it looks like 90 units here. The marginal revenue label's way over there, but it should be here. So this graph is a little sloppier than usual. But you would say 90 would be would be how much the monopolist would produce. And most people got that right. Good. We're cruising along here. Same diagram. What price? Okay, well, once again, all you want to do is read up from 90 to hit the demand curve. That looks like 10, right? So that gives us, right, okay, good. Well done. A couple game theory problems. What are we on here? 22? I think we'll make it. Okay. Okay, suppose, this is, by the way, a terribly constructed question. I don't know if I did this or someone else did this, but you'd really want to have it like that, right? It's just, you'd want upper left to be, if you think about our Ajinomoto ADM examples, that was kind of how they were structured. So it's a little hard to read, but that's the, Okay. So, yeah. I do describe it up there how it works, but it's not, I don't want to, befuddle you with bad displays here. Okay, so what do I say here? Suppose that the row firm selected action B. What is the best response of this by the column firm? Well, let's see here. If row chooses B, column is comparing 1,000 and 1,500. Column should choose little b. right? So what I had in mind here is you would type that in, and let's see what happened here. I don't know why I keep doing that. Little b, and okay, a lot of people got it right. I can't help but think that maybe, so you can see here what happened. People put in payoffs, all kinds of things. It's a little confusing. Same matrix, right? And now I say, what is the Nash equilibrium of this game? Well, it's always fun to think about this, and maybe in the interest of time, I will do this the quick way and say, all right, well, let's see here. Do firms have a dominant strategy? It looks to me like Rho Player has a dominant strategy. That would be choosing capital B, right? 3,000 greater than 2,000, 1,000 greater than 500. B is always better for the Rho firm. Given that, what should A firm do? Well, let's see, 4,000, if firm, this B is, Rho Player is choosing B here, 3,000, 2,000, 1,500. Column firm has a choice between 1,500 choosing B and 1,000 choosing A. So it looks like B is the best response. So we find that the Nash equilibrium is B, B. So if you look at this, by the way, and you look at how the payoffs are configured, you can see that it is in fact a kind of a skewed example of a prisoner's dilemma game. So, there's a click a target answer. How about that? And there we have the heat map. Kind of cool. Yes? Okay, so remember, you can't just look at the payoffs. I mean, it's certainly true that both firms are better off up there, right? But you can't just say, okay, well, what are the highest payoffs? You have to say, what is the strategic, actually, okay, well, no, there's a problem here. I'm confusing myself because of the way I wrote the payoffs here in this game. So let's think it out here. What if Rho Player were to select capital A? What's the best response of column player? It's to choose little b, right? Because if A is chosen, column player says 4,000 is great, 5,000 is even better, right? So it can't be a Nash equilibrium up there, right? It's unfortunate because, Rho Player would say, come on, column player, just stay there. Then we all do better. Because I know if you're going to go to B, well, then my best response is to also go to B. And now we're stuck down here in this crappy world, right? That's a good question. That's a good kind of illustrating the point here. Well, actually, I'm going to back up and just look at this here. So you can see here, people just that was the popular option, was to click up there where AA was, right? That was the most popular thing besides the right answer there. So this was the side-by-side diagram. We talked about it in class. I didn't ask you about this on the exam, but it's nice to just kind of, fleshes out all the logic. What is in a short-run equilibrium, what is the equilibrium price of the product? So the idea would be here in the short run, forget about this. I don't know if you have enough detail to answer this, right? Oh, okay, yeah. So this is way too subtle for a question like this, but I'll talk you through what I was thinking when I made it. Okay, so here we have demand and supply. They create a price of $1.40 here, right? And then that comes over to the firm, and the firm maximizes profits by setting price equal to marginal cost, right? So the equilibrium price should be $1.40, and the follow-up question will probably be, what does each firm produce at this price? Let me do this, show correct answer. Okay, so people followed my kind of subtle logic there. What amount does the firm produce? It should be 39. Most people got that as well. Once again, that was because that's right here, right? where marginal cost and price are equal. Now, what amount of profit is the firm earning? This is tricky, but what we want to do is we want to say here's price, here's average cost when the firm is maximizing profit. So you'd want to go 39 units. This distance here we can see is 20 cents, 140 minus 120, right? So we'd want to go 39 times 0.2. What is 39 times 0.2? $7.8 is what I get here. Now this is wow, and people got that right. Okay, great. You know, that's I gave you a little margin for error there in this one, but that was one of the illustrating a lot of the ideas. And then there's an inevitable next question here. In the long run, what will happen in this market and why? Well, in the long run, you would expect there would be entry because there's profits, right? As entry occurs, supply should shift out, and ultimately, the quantity will settle here, or supply will settle here, and the firm will settle here at this zero profit point. So you could say, in the long run, the price will be $1, and firms will each produce 30 units. But I don't know how I expected this to, multiple choice. I gave you a much more detailed answer than I asked for, right? You would say, since firms are making profits, there will be entry, right? That would be the best answer there. And everybody did pretty well on that. Okay, I think 28, 29, we have a couple more here. We'll finish them up here. Equilibrium price in the long run should be $1, as I just said, where the minimum of AC and MC is. So people did pretty, oh, wow, great. What quantity will the typical firm produce? Well, the answer should be 30. Part of the same question that we did. Okay, good. Oh, now Coase, finally. In his research, Coase emphasized the role of blank in creating externality problems, and C was what it was all about, right? Lack of property rights. Please watch the video if you from last class. If you want to take in a little My Little Pony and you missed the lecture, it was a crazy, crazy day. All right, the hoteling model now, the model of location. The Nash equilibrium locations chosen by firms. So here we talked about what the Nash equilibrium was in my practice exam, but here I add in what we think about this from the perspective of society. And A is the answer there, right? It's not the best for society, as all the firms wind up clumped up. The way we talked about this in class was we said what we'd want is for the locations to be chosen to minimize the distance that the typical person has to go. Right? That's not right in the middle. It was something like at the 1/4, 3/4 position on our line segment. So A is a good answer for this one. And there we go. So that's all of the practice materials. I can leave this up here for a second. We'll see you Tuesday for the exam. If you have questions, I'll be around all day Monday. Tomorrow's going to be a little tough for me because I have something else I have to do. But I can also do my best with email.